Hello and welcome to Software Architecture course. We will continue with design patterns. So in this lecture, we will study the structural design pattern. In this lecture, we will consider a set of design patterns that are important for structure. So from decorator, let's move to another pattern called the adapter pattern. So adapter pattern is essentially it basically simulates or mimics the adapter in real life. So what you see in this slide on the left is basically a plug. Now this just observe the shape of this plug. This could be a client. So this client makes a request. Basically this plug requires power, and the power is there on the wall socket. So this plug requires the power from the socket, so makes a request. Now here comes the adapter. This adapter essentially takes as an input in this diagram, basically allows this plug to fit in here, but as an output it can basically give this kind of shape plugs. So essentially it converts this shape to this shape. This could be American plugs, and this could be possibly maybe European plugs. So now it is transferred to the socket here. So this is the power supply, where there is a power here, but you see the shapes are different. So this client cannot directly use this and get the power. So you need an adapter which basically takes this shape and then basically creates this kind of shape, and then this is so that this shape can go inside this socket, and then the power can be provided. So in a sense, this is an actual service provider or adaptee, and this is the adapter. This is the adaptee, and this is adapter, and this is a client. So there are three parties involved: a client, adapter, and adaptee. Thus, adapter is basically a bridge between two objects. In general, one class is expecting some type of object, and you have an object offering the same feature, but it exposes a different interface. So in that case, instead of re-implementing either the client or the server, you can implement a lightweight adapter, which basically can take the client request and then pass it to the server. So that becomes easy to implement. But client and the server, maybe they have been implemented earlier. It is steady and running in production, and it is not possible to really touch those servers. Like you can't change the interface of the server, or you can't change the interface of the client, because both are kind of running, and that shouldn't be disturbed. In that case, the only option is to basically implement an adapter in between. So let's look at the class diagram of the adapter pattern. So here in this example, there is the media player interface, and this media player interface supports a mechanism of playing. Now media adapter actually implements the media player interface, and it behaves as if this is the media player. So the media adapter has a method called play, because it implements this interface, but it really does not play. It actually calls, let's say in this example, a VLC player, which can play different types of media like AVI, MP4, and so on. It actually calls a VLC player appropriate method in response to the play request from the client. So there are some terminologies. For example, media player interface is called the target, and VLC player is the adaptee, and obviously media adapter is the actual adapter. So this adapter class actually implements the target interface. So the main benefit is that adapter lets different classes work together, like Play My Audio and VLC Player, that could not otherwise work because of incompatible interface. Like Play My Audio and VLC Player would not be able to really interact with each other because of incompatible interface if there is no media player, if there is no media adapter. So adapter class holds a reference to the adaptee, otherwise it really cannot pass the request. So adapter class must hold a reference, and it translates target methods to adaptee methods. It translates these target methods essentially, that's here inside this, or rather this is target method is play, though it has got a it's just a interface, so it's just a method definition. So play is the method, and inside this play method it is going to call this VLC player. That's the way it's going to work. So in other words, the adaptee is actually wrapped. It's wrapped into an adapter class object. So if you look at the example here, how it is used, so the code for play method of media adapter might look like this, that you might just write an if statement. If audio type equals to AVI, then call VLC players play AVI media and pass a file name. Or else, if the audio type is MP4, then you can actually call VLC players play MP4 media method and pass the file name. So in this case, the composition basically plays an important role. This composition plays a very important role here. So now let's look at the usage of the adapter pattern. So I have my client class, which is Play My Audio. This public class Play My Audio has a main method. So inside this main method, observe the way I am calling this adapter. So media player interface player is a new media adapter. I'm creating a new adapter, and then what I'm saying is player.play, and I'm passing the file name, which is an AVI file. Then I'm again calling player.play, but this time I'm passing an MP4 file, and this adapter takes both the files, and then depending on the file type, it actually calls an appropriate method of the adaptee. So third-party libraries and framework is a good example of using adapter pattern. In many applications which actually use third-party libraries, they actually use an adapter as a middle layer between application and the third party. Basically it is there so that the application is completely shielded and decoupled from the third-party library, because if you want to change the third-party library and provide another one, then all you need is to just change the adapter. Client remains the same. Because of that reason, adapter is heavily used in this case. So that's what I said, that if you want to change a third-party library, then only adapter for the new library has to be designed again. The rest would remain the same. So the question here is that how much should the adapter work? How much of business logic you want to put inside the adapter? This is not a very easy question to answer. So obviously it should do only that much which is necessary for that application. Now what is the necessary part? What is beyond necessary part? That's completely dependent on the application domain, the requirement. One cannot really generalize. Now if the target and the adaptee basically are similar in nature, then adapter can just pass the request from the target to the adaptee. And however, if they are not similar, then there's a problem. Then adapter may have to convert the data structure between these caller and the adaptee, and it might also have to implement operations. Sometimes it may be required to implement operations that are required by the target, but that's not yet implemented by adapter. In that case, it kind of becomes a proxy. It implements the feature at the adapter level itself. It will not really pass the request to the adaptee, because adaptee may not have implemented that operation. So this is actually useful when these operations are really simple in nature, simple and very specific. It's not really generic. In that case, the adaptee might have already implemented it. It's a very specific application specific requirement, and it is really not a major one. In that case, you could write that method inside the adapter class. With this we conclude. We'll continue with other design patterns in the next class.